Hello, my name is Rich Howard, owner of Architectural Builder Supply. In this video is to bring you a closer look at the Bommer number LB8004-504-652. This is a heavyweight, full mortise, lube bearing, steel base, satin chrome plated hinge. So let's take a look at this hinge and what it is and what it's all about, where we're using it, why we're using it. First, a visual tour of this hinge. Might start off by looking a little unusual. Okay, so my first scenario, it might strike you as tall. It is. It's a tall hinge. It's also a narrow hinge. We open it up and it does look equally interesting. The reason it does is because it's a 5-inch tall hinge, but only 4-inch wide. Not a typical hinge, but it's a smart hinge in a certain very common application. And what we're going to do is we will dissect the part number is what we're going to do, and all pieces. We're going to talk about the extended description information, the template we're going to take a look at as well. So let's start with a proper dissection of the part number, and we're going to look at the product catalog along the way. Okay, so the way to dissect that part number elegantly is to hop over to the manufacturer's catalog page, which was here, and then that's going to open up the manufacturer's catalog page within our site that will allow us to get to the product catalog. And here it is, product catalog. Okay, click on that, that'll fire up that document, and I'm just going to scroll through quickly because I have an idea of where our LB8000 series is going to be. So first of all, a couple of things happen. When Bommer goes to a concealed bearing, 3-knuckle, when Bommer goes to a concealed bearing, it becomes a 3-knuckle hinge. And that is the LB8 part of the part number. The concealed lube bearing is made from a special nylon bearing material and is maintenance free and requires little to no oil or grease. Okay, I wanted to use a 3-knuckle hinge on this because it's a cleaner look, is just simply the bottom line. But we're looking at an LB8004, and that cut sheet is going to be linked down below here as well, which shows us that this is a heavyweight lube bearing, they call it, steel-based hinge. We're doing a 5x4 right in this area here. Because it's 5-inch tall, it's 190 thousandths of an inch thick. Okay, now let's further dissect the part number, and that is on page, at least this current document, AH5. So down here, we have LB for lube bearing. This project I'm doing for a Chicago contractor who's doing a project at the primary airport in Chicago for the anchor tenant at the airport, airline. And it's some interior refit, you know, back of house operations, whatever it is, maintenance it might be, facilities for their employees. And I wanted a hinge that could handle this door. This door is 4070 16 gauge steel stiffened. Okay, so I wanted a door that could handle it. I like the 3-knuckle design because it gives me the LB, which is a really great construction in terms of handling the weight of a door. I wanted the weight of the door to be handled elegantly. That meant concealed bearing, which meant 3-knuckle, which is nice because that is a snazzy sort of look, so to speak. As we continue to roll through the part number, we get, and remember, we're dealing with LB8004, so we have a 0 here for full mortise. We'll go over that in a moment. We have zero in this column, which means it's a standard hinge, in lieu of it being some sort of a alternative type of hinge, such as raised barrel or wide throw or these other variants of hinges. Then that last value is 4. That does mean heavyweight and steel based. Okay, then we get over to the size, but let's first dissect what the full mortise looks like. Now the full mortise part, we hold this hinge like this. You can see from the bend in the hinge leaf here, it's better illustrated here. That's called the swag. When the leaves are brought parallel, they're meant to be mortised flush to the edge of the door and the frame. That's the swag. That swag makes it a full mortise hinge versus it being a half mortise or a half surface or a full surface. It's exactly that bend in the hinge leaf that defines it as full mortise. Okay. We can see why it's 3-knuckle. And I said earlier it's a cleaner hinge. I believe that it is. I believe it's a much cleaner hinge. That tip is buried down. It's been set into the hinge barrel. You don't even see the barrel at all. Super clean. You can obviously drive it out. This client will likely need to. But it's nice and concealed. No bearing packets that look out of alignment. No button tip hanging off the top. This is a non-rising, very elegant tapered sort of pin that's here. Clean look. Let's jump over into the part number. Bommer has a unique naming structure when it comes to sizes. You do need to be careful when you're ordering this because you might order the wrong size. Their chart that's on that page should be referred to. And once you do it enough, you just end up memorizing it. But for instance, the hinge that we have here, a 504, is not even listed there. They can't list them all. I mean, you know, what about a 6x5? Well, but you get the concept of how that works. To a certain extent, I suppose you do. Anyway, this would be a 504, and that means that it's 5-inch tall and only 4-inch wide. 5-inch tall. The first dimension on a hinge is the height. That is the primary dimension that we're concerned with. It's the dimension that's more important rather than the width. Why do I say that? First of all, you need to know the height is the first dimension. That has to be known, because if I was making doors and frames for 5x4s, that's going to be a different preparation than if I was making doors and frames for 4x5s. We have to know what the first dimension is. That's the important thing. Why is it more important? Because generally, the height of the hinge tells us, gives us an idea in terms of the size of the door, the weight of the door, gives us an idea of the thickness of the door as well. The width of the hinge is important, but I think secondary, because it's a number that we have to determine based on our compatibility, but it's more agreeable to subject to what you'd like to have or what you can have. Generally, the height can't be argued, okay? The size of the door, the weight of the door, the thickness of the door, that's going to determine a height. And there's not a lot of, and when you follow best practices, there's not a lot of wiggle room in terms of arguing for something else. The weight of the door is going to really help you determine the size of the hinge, okay, the height of the hinge. I should say the weight of the door and the frequency of use. This is a 4.0 door that is 7 foot tall, 16 gauge steel, stiffened as I had said earlier. That's going to have moderate use. It's best practice in the industry when you have a door wider than 3 foot, or maybe someone might say wider than 3'6", go with a 5-inch hinge. Well, 4.0, okay, on the outside, for sure, 5-inch hinge, 16 gauge steel stiffened. It's going to be a very heavy door. I'm going to go with a 5-inch hinge. I'm going to go with a heavyweight hinge as well. And that was in the 4 in the part number. That in a 5-inch height, that's going to be 190 thousandths. When I put my caliper on this, my caliper tells me 0.193. 0.193. So it's a big, thick hinge. Now, let's talk about the height of the hinge in terms of what sort of frequency and weight rating we could probably expect out of this. The height of the hinge has everything to do with the frequency of use as well. You know, you can have a hinge that will go, that will go 1,000,000 cycles easily, given a certain frequency of use. That same hinge where it's very low frequency may last a century. So if you're dealing with a 5-inch tall hinge, a heavyweight 5-inch tall, I'm looking at a little chart that I have here. If you're dealing with a 175-pound door, you're going to be able to expect that to operate on a medium frequency sort of application. You get into a door that's going to be considered greater than 225 pounds, that's going to force that down into being low to moderate use when you're dealing with a 5-inch heavyweight hinge. You get into a scenario where you're at 300 pounds, that's going to put you to a low frequency of use. To become high frequency of use, you're going to be up to 175 pounds. Would be my best guess in terms of that. You need to hang something beyond 300 pounds. You're really dealing with either hardware that's rated for prison weight doors, or you're getting into pivot hardware as well. You know, I really feel that anything hung on anything that's more than 225 pounds, that's where the cutoff is to really start thinking about pivot hardware, because all that weight is borne on the earth. Okay, plus about 225 pounds is generally where you're going to see surface applied closers stop in terms of being able to have a statement from the manufacturer that says, yes, our door is going to close our closer will get a door closed that's 225 pounds. So at that cutoff, I've noticed, let's start to rethink the entire process. Okay. Now, the width of the hinge is a conversation all onto its own, and let's start with the width of the hinge. Now, if you recall, we're dealing with a 5-inch by 4.5-inch hinge, and to just draw ourselves a small little frame profile here, okay, we're going to have our hinge leaf set in here. Forgive the poor sketching that we're dealing with. Okay, now your door is going to come in here, okay. Vertical axis of pivoting is right here. Now, the standard size is 4.5 inch. It's just the size that we generally find to be, I suppose, compatible with most uses. And when you're dealing with an application where, well, let me put it to you this way. The width of the hinge that you select is worthy of scrutiny based on your application. And here's what I mean. If I have an application where my wall, I've got my studs, my frame is literally going to wrap the wall. The vertical axis of pivoting, it would be smarter to draw that as close to the face of the frame and door as possible, because the hinge becomes more efficient. Okay, it's bringing that load closer to the load itself. It's bringing the vertical axis of pivoting, carrying the load closer to the door itself. However, if you have a scenario where you are dealing with, let's say, this sort of application, where you're going to bolt the frame to the wall, now you need to think about, okay, where do I place that vertical axis of pivoting in relationship to the face of the frame so as to accomplish the degree of opening that I'd like to accomplish? Okay, so what I mean by that is, take that same profile, then we've got our wall, we've got our hinge, forgive the poor drawing, you get the illustration. But when I take this door and I move it out like this so that I bring the door out here, it's backwards. When I bring the door out here, I need to think about, what does this hinge look like when it's in this orientation, and what does the vertical axis of pivoting need to be from the face of the door so as to accomplish my degree of opening. If I'm going to 90 degree, it's no big deal. But if I want the door to go to 180 degree, you know, I need to think about that. What is that dimension? But in those instances where you have a frame that wraps the wall and the frame is actually, the jam depth is deeper than the application otherwise, a vertical axis of pivoting that is closer to the face of the door would be considered best practice. Okay. Another reason that you would want to keep the hinge as close to the face of the door as possible is because you have less projecting hardware. It's just the bottom line. It's going to look more pleasing, you know, basically when this is closer. And if you study aluminum storefront, if it's hung on butt hinges, those are very often just a 4-inch wide hinge. Okay, so if you've got knockdown drywall frames and you're wrapping walls, go with that smaller size. That is indeed what we're dealing with on this project, where we have deep frames. They're 8 3/4 jam depth, not especially deep, but they are wrapping our 8-inch CMU. And the doors are only going to go to 90, maybe 120, but there's no reason to have that hinge barrel hanging out. And as I had stated earlier, it's already a very heavy door that will have high volume use. And I want the mechanics of the hinge to be as well suited as possible to bring that as close to the center line of the door as possible. And that is evidenced by, you can buy floor closers that will hang very heavy doors, but the heaviest of pivots will always be center hung. We can do, and we have done, pivot hardware for 3,000-pound doors. That is certainly going to be center hung. You won't find an offset hung for that sort of weight. And while that's an extreme example, it does illustrate getting that vertical axis of pivoting as close into the center of the thickness of the door as possible is all we're really trying to achieve. Plus, in my opinion, it just looks better. And when, again, in my opinion, we're dealing with a attractive 3-knuckle concealed bearing hinge, let's suck it up back to the face of the door and make it look as nice as possible as well. So now let's continue on with a review of the information. Let's take a review of the finish of this hinge and then the extended description. Okay, let's get to that last part number, the finish in the part number. The finish is 652. That's going to mean two things. It's going to mean that it's made of steel. We also know that from the 4 in our part number as well. It also means that it is satin chrome plating over steel, and that all conspires to be the most durable of all artificial finishes, meaning you've got a finish over a base material that is some sort of plating, some sort of process has been done to it, rather than just polishing it or brushing it. The most durable of natural finishes would be where you have a brush over a base material, which would be stainless. If this was a LB8006, that would give you a stainless base material, and that would be a brushed finish. That would be the most durable of all possible finishes. Solid stainless with a brushed finish over it. This would be a good alternative. We're not using stainless on this job. This is interior. No reason to have the cost. There's no reason to justify the additional cost. There'd be no advantage really to the client. Okay, so that's the finish. Now Bommer is quite proud of their ability to. They have 33 or 34 standard finishes. They have their entire plating department. It's an absolute standalone, massive operation that occurs there, and they're quite proud of their plating operation. I've seen it in action, and I've seen it work, and it's very neat. It gives you a deep appreciation as to exactly what it takes to make a hinge. You might be able to say to yourself, making a steel door is difficult. I would argue that making a hinge is actually more involved. This would be for the extended description down below. This would be for heavyweight doors, high frequency use, steel hinge, steel pin. This is A8111 ANSI rated. This is template. The location of the holes. There is a link below this video called cut sheet. By the time you're seeing this video, it'll probably say template. We're going to get to that next. This is a 3-knuckle hinge, as we determined earlier, and lube bearing, concealed, maintenance-free, very robust, flush tip pin and plug, 190 thousandths. Regarding the screws, this will come with screws, and that template will show you where the holes are for the screws. This happens to have all machine screws and all wood screws. And that's really great. That doesn't necessarily mean that you're going to always get that. Not every manufacturer sends all machine screws, all wood screws. Bommer doesn't necessarily send it either. Quite frankly, the best way, the best practice, the proper way would be to define your fasteners. What sort of fasteners do you want? All wood screws, all machine screws, half wood, half machine. That way you'll be able to convey to the factory what your requirements are. Are you going to use this on a wood door and a wood frame? Probably not. The factory might conclude that as well and send all machine screws or only half wood screws and all machine screws. And you might call and say, I don't have enough wood screws. Okay, what did it ship with? Well, they only sent me half wood screws. What's the door made of? Wood. What's the frame made of? And you're expecting them to say steel, and they say wood. So convey that information, because let's not rely on getting all machine screws, all wood screws. You know, there you go. Now let's take a look at that template document that's down below. Now down below, there will be this will be named template probably by the time you're seeing this, and that's going to allow you to pull up this hinge, the location of all of its screw holes, and by all means, if you are replacing an existing hinge, I would definitely take a look and see to be sure that that is going to be absolutely compatible with what you're doing. Okay, there are columns here for the different part numbers that all comply with the way that this is drawn. Steel hinges in your 3-knuckle concealed bearing, you're going to have a 4 over here in the last part number. That'll give you that heavyweight. You switch over to a brass or a bronze, you'll change that to a 5. You go to a stainless hinge, and like I said earlier, you'll change that to a 6. And then you can see how the A dimension, from the leaf to where the swag line starts, changes as the width of the hinge changes from 4 to 4.5 to 5 and all the way out to 8 inch. You can see how that number changes. Okay, they obviously won't make a LB8000, and that number right there was our that was our standard hinge. That 1 means wide throw, so that's why it's going to be tossed down in here. Okay, you're picking up a 1/4 inch when you go from 4.5 to 4, a 1/4 inch. That's nice. Tuck that hinge back, as we said earlier. If you're not sure what you need, take a close look here. That'll help determine what you need in terms of what you're matching, or what you're going to be sent, I should say. Let's talk about some options, then wrap up this video. Now, options on a hinge like this are generally going to be security options. N in the part number would be 504N. If you wanted a non-removable pin, that's going to give a set screw preparation right into the barrel of one of these hinges, so that from the outside you won't be able to get your screwdriver, your Allen wrench, on that set screw to help drive the pin out. It just won't be accessible. NRP, non-removable pin, is the most common method of a security feature on a hinge. This is an interior door that it has a passage set on it. So we're not talking about non-removable pin. It just happens to be a big, heavy door with a passage set. You can also do a security stud feature as well. And let's see if Bommer discusses those features for us, which they do. Okay, so they're going to be able to give you a security stud, and that is, in essence, going to be a large, thick disc that's attached to the hinge with a hole on the other side, so that when you close the door, even if you were to drive the pin out, you still can't separate the leaves because of that stud that's sticking into the other leaf. Very common to do a non-removable pin with a security stud. The Miami International Airport, I've seen those hinges there going out to the parking garage. Maximum security studs. Studs are attached to the back of both hinge leaves and project into holes in the hinge reinforcing plates. That's when the studs are back here, going into a hole in the plate. That will, again, permit you from separating those leaves apart. You know, I don't really see how you're going to be able to pull the door out, even if you drove the pin out with a maximum security stud. You know, you've got a big chunk of metal hanging into the into the hinge reinforcement. You'll have to see that option with a hospital tip, and that's where they're going to take this and literally grind that down so that you can't hang anything on it. It's another reason I like hinges that are smaller. There's less behavior of hanging things on it. it becomes somewhat ligature resistant at that point, is the purpose of the hospital tip, okay, as well. Very nice caliber hinge that we're dealing with here. Now, looking at the balance of the extended description information, decorative tips, they can be done. You're not really going to see those at all when you have a flush pin. I can't say that I know that we can do steeple tips on a hinge like this. I don't know if we can do it on their LB series. I will ask that question of the factory and update this profile accordingly. But you can do radiused corners. That would be super unusual, but not unheard of. I have done heavyweight 5-inch hinges for a client who wanted 5/8 radius, and he had an application where he, believe it or not, that's what he had. He had 5/8 radius on a 5-inch heavyweight hinge. Now, finally, there is a link below this video to the manufacturer's page where you can pull up not only all of the Bommer products that we sell, but also a link to the manufacturer's website, as well as a link to the full product catalog. You can see this is a neat, clean hinge, well manufactured. The last thing I'd like to point out to you is the Bommer logo, and right above it says Made in USA. That's a fact that Bommer is quite proud of. As am I to represent them. They're the only hinge company who can make that claim, that they're made in the United States, along with their material being sourced domestically as well. And that's contiguous United States, not Taiwan or any other foreign country that is Buy American Act compliant. 100% domestic in every respect. The pens that those folks use are 100% domestic. Maybe it means something to you, maybe it doesn't, but the fact of the matter is I'm proud of it. They're incredibly proud of it. I think it's a great caliber hinge, great quality hinge. Any questions on the LB8006-504-652 or any other Bommer product, please feel free to reach out to us. And thank you.